So sheet 1 is on sets. The first question to verify the laws of associativity, distributive, and Morgan's law. These are rare questions, but if we are asked, let's take advantage. So we move to question 2. Question 2, I want to solve question 2 again. So I'll solve question 2A, I'll pick 1. And question 2B, I also pick 1. Because this has been the area of concern in most cases. So question 2 says, A, let x be equal to negative 10, 10, none of them included, and let A be equal to negative 2 to 6, none of them included, B be equal to negative 5 to 3, both of them included, and C be equal to negative 1 included to 8, none included. So we'll pick the question A, I'll pick part 5, which is A intersection B minus C. So A intersection B minus, then maybe I also pick part 6, just to demonstrate the thing, X minus C complement, and then intersection A minus B. So the first one is A intersection B minus C. So let's look at B minus C. B minus C is the same thing as B intersection C complement. B intersection C complement. So B intersection C complement, we get the set B, that's negative 5, comma 3, intersection. Now let's look for C complement. So C complement comes from the universal, which is X. So when getting the complement, you go to the universal and start with the boundaries of the universal. Negative 10 from left, not included, comma, you move all the way up to where C is starting. So C is starting at negative 1. That's why you end getting the complement. Union, you start again at 8, all the way up to 10, not included. Now, negative 1 and 8, which one do we include? Which one do we exclude? Negative 1 is included in C, meaning it's not in the complement. 8 is not in C, so it must sit in the complement. So now, this is one set. This is one set. So I want to get the intersection of these two sets. So, negative 5 to 3 versus negative 10 to negative 1. If you got the number line, must look like this. It's more than why I got this question. The number line will be 10 to minus 10. You must show on your baseline that you understand that when the universal is negative 10 to 10, I must show my universal there. I don't put arrows because arrows are for the set of new numbers. So now, let's get the intersection. So we have negative 10 to negative 1 for the complement. We also have 8 closed to 10. Then we bring in -5, -5 to 3. So included and included like that. So we want the intersection. So you see, the intersection is here. So the solution is going to be -5 to -1. -1 not included, -5 included. The answer we have found is B minus C. So we need to go back to our question and now complete it. It is A intersection, what we have found. That is A is -2 to 6. Intersection, the answer we have, -5 to -1. Okay, so again, on the base, -10 to 10. And then from -2 to 6, we have A. We also have from -5 to -1. Closed, open. We want the intersection of these two. So as you can see, the intersection is here. That is from -2 to -1. Both of them not included. So this is the final solution. Okay, that's the final solution. So from there, I said I also comment on part 6 so that I can demonstrate something. So when we have the complement outside, so we take it inside first. So we have X complement. Or before we take it inside, we need first to deal with the minus. So we change it to intersection C complement and then complement. Intersection A, intersection B complement. Then now we take the complement inside X complement union C. Intersection A, intersection B complement. X, hello?
Sorry for disturbing. I wanted to ask on when B minus C is in the bracket. So meaning that when it becomes intersection, the complement, how do you simplify it?
How do you?
How do you expand distribute the complement?
Which complement?
Like when it's B minus C in the bracket.
When it's B minus C.
Yes, in the bracket, the way it is question 5.
Uh-huh.
So I wanted to say, so meaning that it just becomes C intersection C complement. That's all.
The way it is B minus C.
Yes, sir.
It becomes B intersection C complement. That's all.
Also, I thought maybe the complement outside the bracket.
No. There's only one minus, so the complement cannot come out of it. Because if you take it outside, it also affects B.
Thank you.
Okay. So X complement, X being the universal, its complement is empty. Empty union C, intersection A, intersection B complement. And so empty union C is C. Intersection A, intersection B complement. So now at this point, it has become a question like part 1, like part 5, which you can carry on and do the number lines and get it. So I just wanted to make an emphasis that if you're doing the complement involving the universal, you would get an empty set. If you unite the empty set with another set, you get that set. And then if whatever operations remain now, you carry on with all the operations. Okay. Then the other one, so we can also do an evaluation of the differences, is part B. Part B says you are given that R is the set of real numbers, is sitting here at the inverter set, and you have A equal to -8,6. Included, not included. And you have B sitting in as 5, infinite. And then they are saying find A minus B. So this means we want to find A intersection, B complement. The interest of complement is for you to demonstrate that you understand what it means to have a complement on the set of real numbers. So since R is the universal, the number right now looks like this. It has arrows. So I wanted to differentiate. When R is not, the universal, there will be no arrows on the number line. But when R is the universal, there will be arrows on the number line. So B runs from 5 to infinity. This is B. So its complement is open at 5 to negative infinity. 1. Then there's A. A is from -8 all the way up to 6. Not included, included. And so we must get the intersection. A intersection B complement. Okay, A intersection B complement. This is B complement, and that is A. So they intersect here. Okay, so they intersect from where? They intersect from -8, not included, all the way up to 5, not included. Like that. Okay, so let's move. This question doesn't miss in the test. That's why we've been doing sets, and we still have to do sets. Just make sure that we are covered. Okay, so on how to simplify, I think we have simplified this one. We simplified here. It will represent a simplification that you can do from on question 3 there. And also question 4. They always, if they want to use terms like disjoint, they will tell you the meaning. That the meaning is A intersection B is empty. So when you simplify, when you find empty, you will be reminded what it means. It was to be defined for you.
Sir.
Hello.
How about this question for in the test 1, the one that was saying that given that A and B are non-empty sets, then simplify. Simplify A intersection B minus A. I don't know if it's just me who didn't understand the English, but then I was finding that A, the answer is like A intersection B, but the solution, it was like an empty state. So I was trying to figure out like how was it an empty state? I couldn't understand. Maybe it's the English I didn't understand. I'm asking if you can explain some for me.
So if you are told that they are non-empty, it just means that they have elements, both of them. So there are elements in A.
No.
They also, it does not tell us how the elements in A and B are related.
But still more when you work it out, it doesn't give you empty sets. No, it leaves you with A intersection B. So I was wondering how A on intersection B was an empty set. Because the final answer was like an empty set in the solutions, those ones for the thing. The solutions for test one.
So what was the question? How was it? It was A1?
A intersection, then in brackets, B minus A.
A intersection B minus A.
Yes.
So if you simplify it, you would say A intersection B intersection A complement, right?
Yes.
If we put diagram so we can shade, we are saying B intersection A complement. B intersection A complement is this part here. Does this part intersect with A?
No.
Because now one intersected with A and A is here. Is there any part where the lines are crossing each other?
No.
So that's the reason why the answer is M.
So you don't have to distribute there. There's nothing like distributive law. I don't know if it's distributive law. You don't have to distribute where you have.
You can actually distribute if you want. You say A intersection B, intersection, A intersection A complement. So you have A intersection B. What is A intersection A complement?
It's an empty set.
Any set intersect with an empty set is empty. What we are solving a problem. We are now bringing a problem. Okay. So take sets as light as they are. Let me exaggerate them. Okay. Then let's go to question 5. Using the set notation, describe each of the following shaded parts in the Venn diagram below. You just need to make it a habit to describe whatever you see shaded so that you can also use the Venn diagram to shade when you're stuck in simplification. You saw what I was doing. I was simplifying. No one told me to use sets, Venn diagrams. I just went that Venn diagram because I can easily see them. So if I can use them, I should also be able to interpret them if I meet them anyway. But like the first one, we want to describe it. So you'd say, okay, the shaded part does not touch A. So because A is not being touched, I will say A complement. Okay. Now there's so much A complement space that is not touched also. Because A complement is everything outside A, but some parts are not touched, meaning there's an intersection somewhere. Okay. Now we see between B and C, the space there is shaded, but part of it is not. So we describe the space remaining and the intersection C. Had it not been for A complement, the B part that is in C and also in A there would have been shaded as well. But because of the A complement, it has been left out. So this is our description. There's no harm if you describe it by separating the two wings. So you could actually use that.
Mr. Keith, I have a question.
Okay.
Yes, so what if we were given something like A complement union B intersection C? What would it look like? Because the boundary there, exists because it's an intersection. But what if it's union?
If we are given a complement,
Union,
uh-huh,
that set there.
like this, it would look like
Yes.
A, B, C. Oh, so maybe we shaded the way to shade it there. We name the way sets are named. Would be A, B, C. So you would say, okay, A complement is here. Union, that is plus B intersection C. I mean B intersection C. B intersection C. Where is B meeting C here? So the whole shared part here will be a solution. When there's union, you don't care whether you're touching the set that you didn't touch in the first place because it's the idea of addition. So you add through.
All right,
Okay.
thank you.
Just a minute. Okay, we can carry on. Okay, so we can also describe set B. A, B, C here. You see that the shaded part is the shaded part, the first shaded part we are seeing is we see A intersection B, intersection C being shaded. Union, we also see A, union B, union C not touched afterwards. So the area outside is A union B union C complement. Plus the area inside is A intersection B intersection C. That's how we describe it. Okay. And then question 6. In a single Venn diagram, illustrate the relationship between the sets of natural numbers, integer z, rational numbers, irrational numbers, and the real numbers. Just give an illustration on a Venn diagram. So you want to say, okay, the illustration will be, if I will have this, I'll have this set, that is the set of real numbers. That is the inverse in that case. And then in real numbers, you should have two sets. The first one being rational, Q, and the other one being irrational. So we'll represent it using P. And then from there, in real numbers, we'll have, in natural numbers, we'll have integers. So we'll have integers, Z. And then in integers, we'll have natural numbers, M. So that's a description on using Venn diagram. The key thing is that rational and irrational do not intersect. And then any other number sits in rational. But rational and irrational, they give us a set of real numbers. Okay, and then
Which set is that one that's alone?
the set of irrational numbers.
Set
So,
of
sir,
Yes.
what if they put imaginary numbers?
What
How
is
can it
happening there?
If they put complex, we would have put another shape here and called it complex. It now becomes the main universal set because all real numbers are complex numbers. So we're attempting to answer question 6. And that's all that is needed there. Don't scamper much. So we didn't have the outer set. We just imagined that, oh, what if they said also complex are there? They would extend outside. Okay, then to express as fractions, this is a thing that you should enjoy doing because you are sure there will be a question of that kind. It's a sure thing. And then show that 1 plus root 2 is irrational. Of course, the assumption will be that you have already been told that root 2 is irrational. So your job is to make sure that the whole sum is also irrational. So just a statement, and then you do the solving where you make root 2 the subject. And then you move. Other questions, at least expect them. So I move straight to conjugation. Maybe I can do one conjugate on B. Since B looks mixed, it has irrational and complex. So the thing is, we have
Mr. Keith, I have a question.
okay.
For example, they give us root 2 as irrational, and then they say prove that 2 to the power negative 3 over 2 is irrational. How would you solve that?
Two to the power negative 3.
Yes, the power negative 3 over 2.
Over 2 like that. You mean like this?
No. Like 2 as the whole number. Then to the power negative 3 over 2, that should be a power.
Oh, the fraction is a power.
Yes, the power is a fraction.
Over 2 like that.
Yeah.
Okay, so this, if you write it, it will be 1 over 2 to the power 3 over 2, which is 1 over the root of 2 to the power 3. And so you know that means root 2 times root 2 times root 2. Root 2 times root 2 is 2. So it could be 1 over 2 multiplied by root 2. And then you start from here to solve now. You know that you relate to be A over B. You give condition, cross multiply to make it to the subject. Is that fine?
Yes, thank you.
Okay. Okay, so I need to demonstrate on B there, that's 11B. 1 plus the root of 2i divided by the root of 3 minus 2i. So to conjugate, you multiply by the root of 3 plus 2i. You use the same in the numerator, the root of 3 plus 2i. That is 1 by root 3, we get to 3 plus 2i plus root 2 and root 3. It's the same thing as root 6, the I outside. And then I times I is -1. So we have 2 root 2. And then divide by root 3 times root 3, you get 3. And then I times I, you get -1, which makes it plus with this minus that is here. And then 2 times 2 is 4. So you now separate. So you say root 3 minus 2 root 2 over 7 plus the root of 2 plus the root of 6, the right I outside over 7. Means you have attended to it fully. Put it like that. So no hiccups.
Sir,
So
why have you put a root on 2i?
a root on
On 2i, on the final answer when you were separating.
why am I
It's a
put
mistake.
the root?
There's
Oh,
two.
okay, it's a mistake there. It's supposed to be 2.